A synthesis reaction is when you take elements and compounds and you add them to make one product. So when you have one thing on the right of the arrow, the right side of the arrow, then it is a synthesis reaction. Decomposition is like decomposing. So you have one reactant that's going to break down into elements and compounds. So you would have one thing on the left of the arrow. So synthesis and decomposition are opposite of each other. A single replacement, single refers to an element. So you have an element and a compound on the left side of the arrow, and on the right side of the arrow you also have an element and a compound. Now it does not matter if the compound comes first or the element. As long as you have one element and compound on the left and one element and compound on the right, then it's a single replacement. If you have a compound plus a compound on the left and a compound plus a compound on the right, then it's a double replacement. Combustion is any type of reaction that releases heat and light. So when you think of combustion, you think of fire. Fire gives off heat and light. Now, combustion reaction, you have a hydrocarbon plus oxygen, and that's going to give you carbon dioxide and water. A hydrocarbon is anything that contains hydrogen and carbon, but when it's written a formula, the carbon usually comes first. The subscripts can be any number, so you could have CH4, you could have C2H8, you could have C2H10. Oxygen is a diatomic, so it's going to be O2, and that's going to give us carbon dioxide, which would be CO2, plus water, H2O. Alright, so if we look at our first problem here, we have silver, and means plus, oxygen. These are elements by themselves, so we have to think about Hofbrinkel. If you have any of those 7 diatomics by themselves, then they need to have a subscript of 2. Silver is not a part of Hofbrinkel, but oxygen is, so oxygen should have a 2 as a subscript. Now looking at your reference table, which one of the things listed on your reference table would match this? Well, we have 2 elements being added together, so this would be the formation of a binary compound, or 1A. And it says A plus B yields AB. So all we need to do is cross our charges and put our elements together. So silver always has a charge of +1, oxygen has a charge of -2, so we would cross our charges. Ag2O. Then we would need to balance it. I have 2 oxygens, 1 oxygen, so I'd put a 2 there. That gives me 4 silvers, so I'll put a 4 there, and it's balanced. Copper to sulfur. Cu is copper. The Roman numeral 2 refers to the charge, but we don't show charges when we write formulas, so we're going to ignore the 2 at the moment. And is a plus, and then sulfur is just S. So again, this would be the formation of a binary compound because I have 2 elements added together. So A plus B would give us AB. So I need to cross my charges. This is where the Roman numeral comes into play. So Cu plus 2 and S is minus 2. Well, because they have the same numbers, they reduce to Cus. To balance it, 1 copper, 1 copper, 1 S, 1 S, it's balanced. Phosphorus is P, and is plus, potassium is K. Again, it's the formation of a binary compound because we have 2 capital letters. So A plus B yields AB. A, though, has to be the metal. Well, potassium is the metal, and phosphorus is the nonmetal. So when I put these together, the metal would have to go first. Potassium is +1. Phosphorus is -3. We would cross our charges, K3P. So to balance it, 1P, 1P, 3 Ks, 1 K, so we would multiply by 3. Lithium oxide. There's no and or plus in between, so this is a compound. So we would cross our charges. Lithium is +1, oxygen is -2. So we would have Li2O, and is our plus, water is H2O. So this is a metal oxide and water. So we're looking at 1B. And it says that your metal oxide plus water yields a base. Now a base is the metal with hydroxide. So the metal in this reaction is lithium, so that would be Li+1, and then hydroxide is OH -1. So when we cross our charges, this would be LiOH. We need to balance 2 lithiums, 1 lithium. I'm going to put a 2. That gives me 2 oxygens, 1 and 1 makes 2. 2 hydrogens, 2 hydrogens, it's balanced. Sulfur dioxide. I have a prefix, so I'm not going to cross charges. I'm simply going to write sulfur dioxygen, 2 oxygens, and water, H2O. So this would be my nonmetal oxide plus water, so I'm following 1C. My nonmetal oxide plus water will give me an acid. Well, acids always start with hydrogen, and I have 2 hydrogens. Oxygen would always go last, so the other element is sulfur. I have 1 sulfur, and I have a total of 3 oxygens. So 1C is always balanced if you write it properly. Decompositions. Aluminum bromide. Aluminum is +3. Bromine is -1. So we have AlBr3, and that's all they give us. So this has to be a decomposition because we have 1 reactant. It's a binary decomposition because we have 2 elements. Aluminum and bromine will decompose into A plus B. Well, A is aluminum and B is bromine. Now I have to think about Hofbrinkel because I have elements. Aluminum is not a part of Hofbrinkel, but bromine is, so we'll need to put a 2 there. Notice that the subscripts are not the same, and they are typically not the same, so we have to balance it. Well, we have 1 aluminum and 1 aluminum, 3 bromines and 2 bromines, so we're going to make them both 6. 2 times 3 is 6, 3 times 2 is 6. By putting the 2 here in front of aluminum bromide, I also have 2 aluminums, so we'll have to put a 2 there, and we're balanced. Copper 2 carbonate. Copper has a charge of +2. Carbonate is CO3 -2. So we cross our charges, Cu, CO3. Since that's my only substance, it has to be a decomposition. So we have a metal carbonate. So I'm looking at my decompositions, and I'm going to follow the metallic carbonates. So 2B. MCO3 decomposes into MO, which would be oxygen, plus CO2. Well, the metal in this problem is copper, and copper had a charge of +2. Oxygen also has a charge of -2, so that would reduce to CuO. And then I would just copy plus CO2. You would have to balance it then. 1 Cu, 1 Cu, 1 C, 1 C, 3 oxygens, 1 plus 2 is 3 oxygens, so it is balanced. Barium hydroxide. Barium is Ba plus 2. Hydroxide is OH -1. cross your charges, BaOH2. So I look at my reference tables. This is a metallic hydroxide, so I'm following to D. The metal hydroxide decomposes into the metal oxide plus water. So barium has a charge of +2, oxygen has a charge of -2, so that would be BaO plus H2O. 1Ba, 1Ba, 2 oxygens, 1 plus 1 is 2 oxygens, 2 hydrogens, 2 hydrogens, it's balanced. Potassium chlorate. Potassium is K plus 1, chlorate is ClO3 minus 1, cross your charges, KClO3. So in my reference table, I'm going to follow along with the with the metallic chlorates, which would be 2E, MClO3 decomposes into MCl plus O2. So my metal is potassium, chlorine is -1, so that's KCl plus O2. To balance it, 1K, 1K, 1Cl, 1Cl, 3 oxygens, 2 oxygens. 2 times 3 is 6, 3 times 2 is 6. By putting the 2 there, I now have 2 potassiums, so I'd have to multiply by 2, giving me 2 chlorines and 2 chlorines. Carbonic acid, it's an acid, so it has to start with hydrogen, which is +1. Carbonic would refer to carbonate, CO3 -2. So you would cross your charges, H2CO3. Because it's an acid, we're going to follow along with the oxyacid decomposes. So this is 2F. You have the acid decomposing into the non-metal oxide plus water. Alright, so if I have plus water, what does that leave me with? The non-metal then is carbon, and that leaves me with 2 oxygens left, so it has to be CO2. So 2F and 1C are the opposites of each other, and they're always balanced if you write them properly. Number 6, potassium is K plus 1. Hydrogen carbonate is HCO3 minus 1. It's a polyatomic. So we have KHCO3. So looking at my decomposition, I'm following the metallic hydrogen carbonate, or 2C. So MHCO3 would decompose into MO plus H2O plus CO2. Well, my metal is potassium, and oxygen has a charge of -2, so I'd cross my charges and get K2O plus H2O plus CO2. So to balance it, I would want to start with my potassium. 1K, 2Ks, I'd multiply by 2. That gives me 2 carbons, so I'd come over here and multiply by 2. That gives me 2 hydrogens, 2 hydrogens. 6 oxygens, 1 plus 1 plus 4 is 6 oxygens, and it's balanced. Combustion reactions always start off as the hydrocarbon, and they always give you the formula. So if you ever have that organic word, comma, and a formula, that name is that formula. You might also see it with the formula in parentheses. So I know that this is combustion because I have a hydrocarbon, so I'm following along on number 5 of my reference table. The hydrocarbon plus oxygen yields CO2 plus H2O. And then I just need to balance it. 3 carbons, 1 carbon. 8 hydrogens, 2 hydrogens. 4 times 2 is 8. 6 plus 4 oxygens is 10, so 5 times 2 is 10, and we're balanced. C4H10 is a hydrocarbon, so I know that this is combustion, so I'm following along on number 5. Plus O2 yields CO2 plus H2O. 4 carbons, 1 carbon, multiply by 4. 10 hydrogens, 2 hydrogens, multiply by 5. That's 8 plus 5 oxygens gives me 13. 13 is an odd number. So what times 2 is 13? 6.5. You can't have a 0.5 though. This coefficient would be 1. So we're going to multiply all 4 of our coefficients by 2. 1 times 2 is 2. 6.5 times 2 is 13. 4 times 2 is 8. 5 times 2 is 10. Now we're balanced. C2H5OH is a hydrocarbon even though it contains oxygen. So this is still a combustion reaction. So we'll have to say plus O2 yields CO2 plus water. Two carbons, 1 carbon, multiply by 2. 5 plus 1 is 6 hydrogens, times 3 is 6. 4 plus 3 is 7 oxygens. Because my oxygens are split up, I don't really want to put a coefficient in front of my ethanol. So I have 1 oxygen, I need 6 more so I can put a 3. 6 plus 1 is 7 and I'm balanced. Sucrose is a hydrocarbon even though it contains oxygen. So this is still combustion. So we'll say plus O2 yields CO2 plus water. Twelve carbons, 1 carbon, multiply by 12. 22 hydrogens, multiply by 11. So that gives me 35 oxygens. Because I already have 11 here, I would just need 24 more. So I can multiply by 2 and not have to put a coefficient on the first one. Lastly, we have C6H6, which is a hydrocarbon, so this is a combustion reaction. So we'll say plus O2 yields CO2 plus H2O. To balance it, 6 carbons, 1 carbon, put a 6. 6 hydrogens, 2 hydrogens, put a 3. 6 times 2 is 12, plus 3 is 15. What times 2 is 15? 7.5. This is a 1. Because I have the 0.5, I'm going to multiply everybody by 2. And we're balanced.